Wait for this. All right, we are live now. Hello,
Okay.
everyone.
Hello.
So today, the talk will be about random walk of the penguins. It's a competition that Ambarish was part of, and yeah, he got the first prize competition. Congratulations on that,
Thank
Ambarish.
you.
So he will be our guest today. I will let him present himself and tell us a bit about his journey.
Okay. Thank you, Sarah. It's a pleasure to have me here in the show. So I just put it around. So I am leading the data analytics practice in TCS. TCS is Tata Consultancy Services, and the energy trading and risk management in TCS Utilities. And I'm in this industry for around 2 decades. So it's been a very nice journey starting from my college days. So I started my journey in IT as a developer, then architect, then I did some project management for quite some time, then business consulting, then again architecture, and then practice leading. And in the meantime, throughout this long, winding journey, I met with a lot of people who did a lot of quantitative analysis, helping the business, driving very major decisions in the business, in energy trading, risk management. From there, I got an interest into the data science maybe 10 years back. So I started learning on my own. I did my engineering from Calcutta University, computer science. So data science, as you know, is a bit of statistics. I don't have any formal training in statistics, so I learned on my own. Coursera, EDX, these open online systems, they helped me a lot in understanding. And then one fine day, this competition came up, and I thought, why not try it? Why not try to learn something? So it was not something that I thought that I would be winning. It was just by chance. And I'll describe the solution to you, and you will also see that it is it is by chance, I would say I won it, because I'm neither a doctorate nor a data scientist by profession. So I dabble in a lot of business, in a lot of data engineering, data science, everything, all mishmash. So without further ado, I will start the competition solution, what it is about, and please feel free to stop me. And Sarah, please interrupt in between so that maybe if I'm not seeing the comments, we can just
Yes.
interrupt at the same.
Yes. Don't worry. I'm with you on
Yes,
this.
yes, thank you. So
Yeah.
let's begin. So this is the competition. It is being hosted by Driven Data, and it was to predict the population of the penguins. Okay, so I'll go into that, but there's a many people involved in this penguin population thing. It is very important. We come to that why. But let me mention the credit to those people. One is Black Box Data Science Limited. Grant Humphreys, I think, leads it. Oceanites, Dr. Hinch Lab at Stony Brook University, US, and the prize for the competition was generously provided by NASA, given an award number. So that makes it all the more interesting. So these are quick facts. Hundreds of algorithms to predict penguin populations. 605 participants, number of entries 675. Not much, because participants usually pour in a lot. So, anyways, so that was the facts. But the most important thing is that why worry about penguin population? Penguins are considered the most important ecosystem indicators. Why? Because Antarctica, there the we can understand the ecosystem, it seems, by studying the penguin population. They are very important krill and fish predators, penguins, and their population tells us about the abundance of prey and the environmental conditions. So, Antarctica, how Antarctica is behaving is important to the whole world, and how it is behaving is depending, or you can say, gives an indication from the penguin populations. But data on penguin populations are very limited, um, because it is out of reach. Antarctica, as you know, is quite far off. And data is very patchy, meaning some data is there, some there is a lot of missing data. And the goal of this competition was to create better models to estimate populations for hard to reach sites in Antarctica. So that why we should worry about penguin population is a thing. Now the counts. Uh, so So the count. So one thing that we must know is that before I entered this competition, it was like I thought that Antarctica is one single continent, and that's it. But to my surprise, it is made up of many islands, many islands, and there are a number of species. There is a gentoo penguins, a chinstrap, adil penguins, and all these things. And these penguin species are interesting. They are different in the sense they breed differently, they eat differently, they are different. So that makes it all the more interesting. Lots of islands, three different species, and you have data, and you're given data to predict. So we come to see what the data was all about. So this is something like the structure of the data that these guys gave. So you find a site ID. Site ID is here. Common name is here, and then there is the uh, years here, and then there is the not null values all over the space. So these so this is a challenge here. You see, there's a lot of values which are missing, and they gave the data from 1900 to 2030. Okay. Now, problem here, if you see the data, there's a lot of missing values, and the time series algorithms, as we see, they are notorious in the sense that if you do not give them proper data, you cannot predict properly. Okay. So this is the whole structure of the problem. So here's the thing. So problem as such is uh, a data science problem can be of two types, major. There are many types, but majorly these two types, if I can segregate. A cross-sectional data problem or a time series problem. So what is a cross-sectional here? Uh, the observations are done at one period of time, and the analysis may not have regard to the differences in time, even if they are not done at meaning at the same time, but analysis is not dependent on the time. But a time series problem is unique in the sense that there is a series of data points and there is a sequence, and it is evenly spaced in time. Okay, so you see here this is a time series problem. Why? Because it is sequenced, it is a population, it is increasing, decreasing, or whatever it is doing. There is a there is a series, there is a time associated. So this kind of a problem is a time series problem. So what is a time series problem? It is a series of measurements of particular phenomenon taken over time. The time series forecasting refers to generating future value for the series of interest. Now, before we go on to the solution, let us first understand the process. This is the most important part because people feel that modeling is perhaps the most important part in data science, but it is not the case in artificial intelligence. It is not the case. There is a lot of steps that comes before modeling. One is that you have to define the goal. What are you trying to do? Here, the goal is simple. You're trying to predict penguins. Next is the most important thing and the most difficult thing, getting the data for the problem. Here, we are very fortunate in the competition that was held by Driven Data. The researchers have gone to Antarctica. They have collected the data. They have spent months and then collected the data and given it to us. So we are very lucky. Somebody has given us the data. And the next step is very, very, very important, and is explore and visualize the series. So why? Because once you get the time series, you have to visualize it. You have to see where it is. Here, I did not do much visualization, but it is a very important step. Why I did not? Because it was not coming out. I did something and then I found that it's so patchy. The data is so very patchy that it becomes very difficult to understand any pattern from it. Next point is the most important point, pre-processing of the data. Algorithms require good, clean data. That is a must. So what we need to do, here's the main thing. You have to process the data, you have to keep the data, um, meaning fill the missing values so that the algorithms can work very fine. So this is perhaps the most important thing. So this is the pre-processing of the data. We will discuss in detail of what is happening in in the data right now. And then another thing, the partitioning the series. Partitioning the series, why it is important? Because you have got the whole data. Now you train the model in a section of the data and you test it on another section of the data. Otherwise, what would happen if you train in all of the data that is given to you, you won't know whether your model is performing or not. And partitioning in time series is important. Many people know that you might do cross validation, but here you have to do the validation in a certain process. What is the process? You have to train uh, the data so that the validation data is not in between the training data. It should be after the training data. That is the difference between a cross-sectional data problem and a time series data problem. So these are the most important steps. Then we apply the forecasting methods. We'll speak about the various forecasting methods that is there, and after that we will speak. We'll have to compare models. So you're building a lot of models. You're building model one, model two, model three, model four, model five. Which one is the best? So you need some sort of metric to identify which model is accurate. So that is where this step comes. And ultimately, after all is done, you have to implement and put it in production. So this is the whole process. So if somebody is just learning the modeling part of it, well, that's not going to work. You have to have a very structured process in in forecasting. If you follow this process, whether you get the right result, wrong result, that doesn't matter. At least you followed the process. You have a method to whatever goodness or madness or badness or whatever you're doing. So this is the process I would recommend. If somebody is doing it, please follow this process. This is not from me. It's from a book, a nice book, Practical Time Series Forecasting by Khalid Shimuli. I bought this book long, 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 long time ago. And this is a good book and very easy to read. So you can have this type of this book is good. Now we did some analysis on the species, it was said in the side. So adult penguin, how many of them are there, and then which sites have how many sites have got adult penguins, how many times the chinsta penguins, gentry penguins. So these are all the data analysis that was there in the site, and we could do all these analysis just to get a feel of what is going on. Now, how would the prediction look like? So we have got the data till 2013, like 1900 to 2013. We have got the data. Okay. Now, what the competition wants is that, so it was held long back. So, what the competition wanted was that what is the population of the penguins at 2014, 15, 16, and 17? So, this is what the competition wanted. So, what is there? There is a site ID, there is a common name, meaning what is the type of the penguin, and then they had the um, then you had to predict the population of the penguins. So this was a format that they wanted. So what you had was that there are combination of the island, there is a combination of the penguin, and you had to do all these predictions. So this is what was expected. I'll just take a pause and I'll just see whether there is any questions or not. Okay, I see a lot of I see some people like from Brazil and India. Okay, thank you for joining. Can I see how many have joined? Sarah, do you know? Do you know how? Can I see how many have joined the? Uh,
Oh, we have like in the live, we have 3 people active, like that are seeing the live right now. But I think
okay,
because there are lots of people who say they would like to, like push it a bit into the schedule. So I think they will see the video after we finished.
okay. That's nice. That's nice. Then not a
But I
problem.
actually have a question for you because like you
Yes.
asked if we had some. So I was
Mhm.
curious about like I'm like I never really played around with time series, so I still have a lot to learn in that. So I'm curious, how do you detect outliers, like, and like for example, let's say someone is interested to start in time series, like what is the first resource they should check? Should it be the math part, or should it be like just the fundamentals, and like what is the best resource to tackle this?
I think for any data, one should just read the data and see of how it looks like.
Mm-hmm.
That is the first part that you should do. Is you should just read the data, see how it looks, and do some analysis on the data. Like this analysis was already done, so you should do some analysis, and then what you should do is do this one. The first thing is explore and visualize the series. So
Yes.
if you're using any tool like a Python or any other tool like a Tableau or something, just go or Altrix or I do not know in your course what you're using, but that's fine. Any tool would help. Excel is also nice. Just
Yeah.
go and visualize the series. So the first thing that you should go ahead and do is just read the data, feel the data. That's my thing is, and one thing is that if you ask a very good data scientist, what they would do is that irrespective of the size of the data, just go ahead and sample the data and just feel it. Just feel or what is in the data, what are the various components in the data, how are they interacting, how is it behaving, is there any seasonality in the data, is there any trend in the data, is there something in the data that you can see. Most people usually get the thing before they go into the modeling. And and just like this one, if you see this data, just like we were seeing it out here, where is that? Yes, you see a lot of, so once you visualize the data, you see a lot of not nulls, right? So that's a problematic data. Is it really worth to do analysis? Obviously, there was this competition I wanted to learn, so why not just take a stab at it? But most likely, you just go back And if it's a business problem and you have access to a business, then you would say, can you please help me to fill up the data? And if they say, no, we cannot do it, it's your, whatever we know we have given you, you just try to find out of how you can fill up the data, then it's your job. But at least you can go back and say that, can you please help me to fill up the data? Because without proper data, these algorithms have no meaning practically.
True. True.
So that is the most important thing, I would say. Visualize the data. So I visualized it and I thought, it's not looking good. So what do I do? Then is the most interesting part. Okay, before I go into the interesting parts of how I solve the problem, some basics are very important. So one is about the prediction accuracy. So I'll take a pause after I cover the basics. So whenever you are doing modeling, one of the most important thing is to choose a metric. So what metric is are you choosing? So there are different types of metrics, and some is a mean absolute error. Don't get bogged down by looking at the maths. It's very simple. It's just an absolute error, and they're just taking the mean. Average error, I don't know why, meaning it's of no use because the negative errors might cancel out the positive errors. I do not know whether this would be useful, so maybe people won't use it. But what people would use is something like an MAE or a MAPE. MAPE is like the error divided by the prediction value, and then you take the absolute, and then you take a mean of it. So that's the mean absolute percentage error. You multiply it by 100. So percentage root mean square is simple. You have the error. The error is the prediction minus the actual. You square it, and then you take the mean, and then you take a square. So if you're not used to programming, you can just do it by hand, and you can do it by any tool in Excel. So these are the things. Okay. So these are the different kinds of measures. Why I say this is important because in a competition, you are measured by the metric. So here the metric is interesting. It is not one of those. It is an adjusted mean. Why? Because they had some confidence in the penguin count. They had an error. So you see the term out here, this term, which they had given in a file, and it's if you see, it's like the map, but it's slightly different. It's the predicted minus the actual minus a max of 1 comma yn. They're doing a max maybe because if it's 0, then it might uh, do something wrong. So they're doing a max, and then it's 1 by n. So this is an important part. So why it is important? Because in a competition, they will measure you by this email. So it was easy for me. I did not have to choose any metric. I did not have to deduce a metric. I chose a competition metric. Okay. Okay. Now the most interesting part. What is the solution? Now, as I said, I divided the solution into two parts. One is imputation, which is a very fancy name. People call things by fancy names. It is like filling up the missing values. How do I fill up the missing values? Because my algorithms do not like, some algorithms are smart or good, they will accommodate missing values, but some algorithms are not that good. They will not like missing values. So I'll have to fill up the missing values. The trick in this competition, which I think one need, is because I filled up the missing values well. Okay. Now let's go to the missing values. So here's a lot of things. Half the things I even do not understand, but I'll try to explain. So why? Because there are very, very nice packages out there in R, which perhaps you know is a great statistical language. There is Python. These two are the most popular programming languages used in data science. So, but if you forget about those, what my intention is to fill up the missing values. So there are different techniques out here. The technique one is time. I I'll try to explain a little bit, but I think somebody has to go in and go deeper to understand it well. I am not the perfect person to explain that. Then there is the last observation carried forward, that is easy. Next observation carried forward and then replaced by zero. We'll try to explain these in the next slide. Okay. So what is time? Okay. Time is interpolation method, which is very much used in oceanographic data. It is what they are saying is 2 and 6 times faster and more accurate than cubic spline interpolation when compared statistically. So, since it is something good, and I really found this gem of a interpolation technique, I'll tell you how I found this. It's by a process. It's no magic. I found it. It's by a process. Uh, the next is the last observation carried forward. What it is, it's just replacing the last observation and putting it there. You see here, it is NA here. The 6 was here, you just put the 6 here. And the last observation carried backward, 7 is here, you put the 7 here. So these are the two ones. Okay. Now here's a bit of code, don't worry about it. So this was my main little function which helped me win. So what I am trying to do is that I am trying to do an interpolation with time, then with the forward method, then with the backward method. And if nothing else succeeds, I just go and replace by zero. And then I used an auto arima, which is like another machine learning algorithm, time series algorithm called arima. And perhaps we'll have to have a different session on arima, but this is a very nice algorithm. And there to find the parameters of the arima is quite difficult. But what happens is that the R package auto arima that finds the parameters for me. It's like an autopilot which finds the parameters for me. So that's about the arima package. So that's the thing. That is the main thing. Apart from that, you will see that I had used a couple of. Oh, I have not shown you. Um, So this is the ARIMA. Then I used another machine learning algorithm, which is called Prophet, which is uh, a time series algorithm provided by Facebook. You can read about it. It is again free. It is available in R and Python. Just go ahead and read about it. I tried different things. So, and the final bit is that what I did, what are the different algorithms I applied. After the imputation has been done, then what I did was that these are the 5 different algorithms that I have used there. There is ARIMA, there is ETS, there is Profit, there is XGBoost and Random Forest. All of it. And then I took the mean. But how many models did I make? Don't get frightened. It was just one program. It got repeated. I actually wrote 5 programs and repeated it for 648 rows. Why? Because there were 648 combinations of the site and the penguin. Here you see the site is here. The site and the common name, which is penguin. So one row, model one. Second row, model two. Blah 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 blah. 648 rows, 648 models. And how many types of models? 5 types of models. 5 types of models, and then I took them in. But if you have asked me if it were not a competition, can I make it very simpler? Yes. One model, that is ARIMA, with interpolation, that would have solved most of the problems. But it was a competition. You have to compete with the leaderboard. So you have to make it accurate. There is very little difference between the first and the second. You have to be a bit lucky, as well as you have to use some technique which nobody is using. So this technique of interpolation helped me a lot, and it was a very small time series. So ARIMA ETS, what we have seen is that it works well when the time series is small, when your prediction interval is small. So that's why it worked, and that's it. After that, the prizes were announced, and then we wrote a paper with all the prize winners. Um, There is a blog out there. I'll show you the site where the blog is. There is a GitHub with all the code. The books which I used, all are free books by Rob Hindman. So this is otex.com, FTP2. You can have a look at the books. All very nice. Everything's free. R is free. Python is free. And I'll just show you the site also. It is uh, drivenbeta.org, competitions, go down, you search for random walk of the penguins, and here it is. If you go down, there is a results, there is a winning models on GitHub. You will not find my winning model, but others also. You go to GitHub, you can see all the winning models people have given. Uh, there is a blog also of the different competition winners. You can read about others, much more smarter than me, who have won. So these are the things. So that's about it from my side. Uh, I hope.
Thank you so much, Ambarish. It was an amazing talk.
Thank you. Any questions from anybody?
No, it doesn't seem like we have any questions. But I would like to ask you to actually, you can perhaps share these like these links directly in the
Yes,
comment
yes,
section.
yes, yes, yes,
Thank you. So that if anyone is interested, they can go check them out by themselves.
yes, yes. I can share them the comments, and oh, I cannot do the comments. So
Oh, you can just send it to me and I will post it myself.
okay, okay, okay. I'll send it to you. Okay, okay, okay. That's nice. I will send all the links and everything. And if you have no questions, that's fine. And there is also, if as part of Udacity, if you're looking for competitions, driven data hosts a number of competitions. There is also Kaggle, which is another
Mhm.
website which hosts a lot of competitions. So please feel free to have a look. And it's amazing because there's a lot many smart people around. They share the solutions, and it's fun. Even if you don't do anything, you can just look at the solutions and learn a
True, you are right.
lot.
At least it's always good to like see how people are doing things. Perhaps you can get inspired and add it in your
Yes,
either
yes, yes,
portfolio or something like
yes,
that.
yes, yes,
Definitely,
yes.
I recommend this as well.
Hmm, hmm, hmm.
Okay,
Okay, okay. If there's
so
nothing
thank you
more,
so much. Thank you so
uh,
much, Harish, for giving us your time and for explaining your solution, and all. Thank you
yes.
so much. I
Thank
mean, I
you.
hope we can have you again.
Yes, yes. There's a lot more competitions that I've entered, and some of them I won. Luckily, though, we can talk. If some more interested, you can see my website also. I'll share the website with you.
Mhm. You can share
Where,
everything here. Like, I don't want to impede you. You can share everything here, and I will share it right now so that it will
okay,
be easier.
okay, okay.
Thank
Okay,
you.
I will do that. I will do that right away.
Aditya, do you have any kind of questions you would like to ask or something you would like to say?
No, that was an excellent presentation. Thank you, Ambarish,
Thank
for,
you.
for the lovely presentation. And I'm quite amazed, like you used an ensemble method with five complex models, I would say, and then get a mean to get a amazing solution. So yeah,
Yes,
It is quite impressive actually, and the kind of research work that you did for each one of these solutions models. Frankly speaking, I haven't heard half of them at all. Like I'd heard of XGBoost, but
So
Arima
that's
of it is something I have not heard. And thanks a lot for there's always something to learn every day.
Yeah,
yes, yes, yes. No
definitely.
problem. Just I think there is this books that I've given, right? It's a magnificent book. This otex.app2, and this one I do not know. I bought this from Amazon. I
Mhm.
think
Okay.
Galit, Galit, Galit's book. She also has YouTube. Galit Shemuli. This might be good, because if you're looking for a product manager kind of a Shemuli, this professor, his books are her books rather. Her books are quite nice. So I bought it from Amazon. Should not be very costly. Long time back. So you can have a look at it. Principles of time series forecasting. She doesn't use in that book. She didn't use to explain R or Python. She used something called Excel Miner, which is an extension of Excel. But anyways, if you don't want to buy Excel Miner or these fancy tools, which is an extension, maybe you have to buy. At least the concept you can understand. I think that would be nice to see explains in a very. She has also got a YouTube channel, so it's.
Definitely. Yeah.
Hmm.
But do you think, like, for example, if someone has never, like worked with time series and they want to tackle them, like, do you think it's okay to, like just play around with the data and then perhaps later on figure out how everything works?
Yes, yes. I think that is the most important thing. You know what? When I started my journey, I just went into Kaggle and I looked at all the great people who have done all the work. And then I would do work. I would just take one line, copy it, run it, copy it, run it. And then I would say, okay, what is this happening? Am I understanding every bit of it? So once you understand maybe 10 lines, that's it. You understand the pattern that person is trying to follow. And once you understand 10 lines, you produce 10 lines of your own, and then the magic continues. And it's kind of addictive, I can tell you. It's addictive. Once you start getting into the fun, it's like playing a game. So
True.
that's it. Okay,
All
I'll
right.
tell you one more thing. This is another machine learning competition
Mhm.
which I just entered. It just ended 2 days ago. It was fascinating. This is also about something very interesting. I think you should have a look. If just read through it. I'll just put it in the chat as well.
Yes,
This
thank
one, this one is from a water utility company. What they are saying, it's in Italy, and what they are saying is that water is scarce. They want to predict the level of water, blah blah blah.
you.
How
Mhm.
do I do it with the data science? It's a real problem by a water utility company in Italy. So that's it. The problem is this competition is strange. They ended 2 days ago and then they told not to share the solution with anybody. So I shared the solution and then I reverted back yesterday night. Otherwise, but it's a similar kind of thing. It's also a time series problem, but it's different. Here you have to. Here they do not know the metric. It's open ended. So read about the problem since you guys are also in this program, you can have a look at it and see of how it is going. So
Thank you.
thank you. Yes.
Thank you, Ambarish. Thanks a
Thank
lot.
Thank you.
you. Yeah,
Thank
thank you
you.
so much for your time.
Yeah.
Yes. Bye.
All
Bye.
right. Goodbye, everyone.
Bye.
Thank you.